together. How we're going to solve a trigonometric equation, okay? So solving trigonometric equations. This is solving the equation at any level. You know that there is going to be one unknown that you have to find it. In algebra, what we do, sometimes we may have to simplify in order to get the x. We isolate the x. We put the x to the left of the equation, and to the right of the equation, we arrive at the number. So that will be the result. So in the case of the trigonometric equations, the unknown is going to be one of those trigonometric functions. So you may have the unknown to be a sine function only, okay? Sine x is the unknown. You may be given cosine x, tangent x, etc. We're going to consider three famous ones. Equation containing the sine only, the equation containing the cosine, and the tangent, because everything else is similar and you can switch it. So what we are going to do in this type of equation, if the unknown is going to be sine x, we are going to simplify the equation and we get to the following special cases. So I talk about each special cases first, because there are some formulas that we have to investigate it, and then we go for it. So the first equation that we're going to consider, we're going to call it, okay, we call this one sine equation. Sine equation. So this is going to be an equation in which sine of x is the unknown. Okay, sine of x is the unknown. So what we do, we may have to do some algebraic operation, okay, adding, subtracting, multiplying, squaring, whatever you need it. But at the end, you are going to have the sine x. You see we have the sine x to the left. So we solve for sine x. When we solve for sine x, we try to let it to be equal to a sine of another angle. Okay, so we have a sine x. We are going to make it into a sine of something like, we call it theta. Okay, so at the end of the day, you arrive at this equation. So this is the equality of two sine, if you like. Sine x equal to the sine of the theta. So one equation, one solution is going to be x equal to the theta, that you can find it from, using your calculator. But just check to see, you see if you go around the unit circle, you see this is going to be unit circle. This is the cosine, and this is going to be the sine. Okay, this is cosine, and this is going to be the sine. Let's see how we can have these. You know that the sine is a periodic function. The period is 2 pi. So one of the solution is theta. So if you pick a theta here from your table, okay, if you pick the data from your table, this is going to be one of the solution. Okay, this solution is going to be positive on the first quadrant. But as we can see, there is going to be another solution. The other solution, remember those leftover, if you like. You see, since they are equal to each other, so we assume that the sign is positive. So if the sign is going to be positive, so you are going to be either in the first quadrant or you are going to be in the second one. If you are going to be in the first one, you get the data, 30 degrees, 60 degrees. Then you have another solution. The other solution is going to be left over in the second quadrant. Okay, so this one over here. So because both of them, you see the sign of both of them are going to be the same. So this is going to be your data. In order to get the second one, this is 180 degree. So this portion over here is going to be pi minus theta. Okay, so if the sine x is equal to the sine of the theta, you already got two solutions. One of the solution is x equal to the theta, x equal to the theta. You let them equal to each other, but there is going to be another one. If you go on the unit circle, you will see it. The other one is going to be this portion over here. This portion is what? Is 180 minus theta. okay, those reference angles, if you like. So this is already is going to be two solutions, theta and pi minus theta. But remember, the sine is periodic function. So this means if you go around the circle, if you go around the circle once, you get 2 pi plus theta. You see, you go around once, then you arrive at the theta again, and you can continue forever. So if we get sine x equal to the sine of the theta, then the result, we say that the general solution, if you like, is going to be x is equal to, we want to introduce the theta, and when we go around the circle, if you go around the circle, we are going to denote this one. You know that anytime you go around the circle, it's a 2 pi. And how many times? 1, 2, 3, 4, 5, 6, etc. So x would be equal to the 2n pi. Okay, 2n pi, n is an integer, plus theta. So that gives you all the possible solution with the data. Okay, if it's going to be 30 degrees, so one of the solutions is x equal to the 30 degrees. But the other one is going to be 30 degrees plus 360, 390. You can go on forever. So you are going to have infinitely many solutions, if you like. Okay, so this is going to be one group. But we have another one. You see pi minus theta. So you can do the same thing with the pi minus theta. So other group of the solution was coming from 2n pi, okay, 2n pi plus pi minus theta plus pi minus theta. You see these two together, when this is going to be when or where n is an integer. So n, it can be equal to the, okay, n is equal to the 0 if you like. An integer will mean that n can be equal to the 0, n can be equal to the positive -1, positive -2, forever. So how many solutions do you have? Infinity many solutions. So this formula that you have to memorize it and understand it is going to be called, this is called the general solutions, the general solutions of the sine equation, Then you may have some restriction, if you like. If you have some restriction, then you see if you replace n by 0, for example, you get x equal to the theta from the first one. From the second one, we get x equal to the pi minus theta. So we get two solutions. If you replace n by 1, 2, 3, 4, 5, 6, we get many solutions. But most of the time, they may ask you for some specific solutions, okay? A specific solution is going to be one between 0 and 2 pi. Those are going to be easy to find. So we're going to explain it for you, how we're going to do it. Okay, so this is going to be sine equation. Any question? I'm going to list all of them, and then I wanted to understand it. Otherwise, I can give you a bunch of formulas and you memorize it. But we want to exactly understand how we're going to get this. Why we get infinity many solutions? Because it's periodic. You go around the circle, you see, come back again. Twice, 3 times, 4 times, 5 times. So we get many solutions. Then if they ask for the specific one, then we can do it and we can replace the n by 0. We get one group of the solution, 2, 3, 4, 5, 6. Any question? Sine equation. Let's see what would happen in the cosine equation, okay? There are 3, we give you the formula, then we go for it. The next one is going to be cosine equation. So if you use your calculator give you only the data. You see x equal to the data. There is no canceling. Some people say, I cancel the sine and the sine x would be data. No, we call it a one-to-one property. Don't say canceling. Okay, now let's see what is going to be the general formula for the cosine equation. So if you see in your equation that there is a cosine x, then you try to solve the equation for cosine x, okay? So you may have, you may have to add, subtract, okay, and etc. Okay, to get these numbers. So that would be the cosine equations. So the cosine equation is going to be, this is it. So if we get the cosine x, if we have a cosine x equal to the cosine of theta, okay, if this is going to be the case, now let's see what's going to be the solution that we're going to have. One of the solution would be x equal to the theta, okay? So you see, this is going to be the case. Let's see how we're going to get the solutions. See what's going to be the possibility for the cosine. You see the cosine is here. And this is going to be the sine. So one of the solution is theta. So this is theta. You see, this is going to be one of your solution. So what is going to be the other one? Okay, you see, the cosine is here. So this is your cosine. So as you can see, if you pick this to be negative theta, if you get the negative theta, the cosine of the negative theta again are going to be the same. Okay,
Yes.
so what is going to be the possibility that we're going to have? One of the solution would be x equal to the theta. The other solution would be x equal to the negative theta. Okay, so these are going to be a specific one, but you know that you can travel. You can go around the circle. If you go around the circle, you are going to have not only the theta, but you go around the circle, you get what? 2 pi plus theta, 4 pi plus theta, 6 pi plus theta. So the first solution is going to be, you see, x equal to, we get x equal to the 2n pi. Okay, 2n pi plus theta. It's important to find the first one. As soon as you find the data, you can find all of them. Okay, any question?
Professor, I have a question.
Yes.
Is it kind of like before how the range for cosine is negative pi to positive pi? Is that where the theta would be?
No.
Oh,
Not the range, the domain.
or the domain.
Yeah, that's going to be the domain that we think about it. You see, you find the data here, you see, you find the data, you know that. And suppose this is 1/2. You see, suppose cosine x is equal to the 1/2. How many angles can you find whose cosine is 1/2? You see, how many angles can you find?
Yeah.
You know the first one. The first one is 60 degrees. But you can travel around to get many, okay? That's why we call it general solution. So we can do the same thing to the second one. So you can get the negative data and just going on and on and on. So people usually put both of them together. We say x equal to 2n pi plus or minus theta.
Yes.
Okay, so that gives you the general solution. So again, this is the case when n is equal to the what? N can be equal to the 0, positive -1, positive -2, etc. Okay, so this is the formula that you have to memorize for the, okay, for the what? For the general solution. And you're going to be in calculus, we have a very special solution that I'm going to show you how we're going to find it. But if you continue taking calculus 2, you need this type of ideas. Okay, the general solutions of the, this is going to be the general solution of the cosine equation. Cosine equation. Okay, so you have to memorize it. The situation, you know, if you just get it on the circle, really, you easily see it and you never forget it to get these numbers. So for the cosine, because the cosine of the data and the cosine of the negative data are the same. So as soon as you get the data, you get a positive negative here. For the sine, the cosine of the data and the cosine of the pi minus theta are the same. You see, this line is just a sine. So that's why we get those two group of solutions. Any question?
No.
Let's do the tangent, then we give an example. Tangent is very popular. It's very easy to work with tangent. That's why they like it. So what is going to be, okay, what is going to be the tangent equation? Okay, so that's going to be tangent equation. In the case of the tangent equation, what we have, we start with this equation. If we get to the situation that the tangent of x is happen to be equal to the tangent of theta, we want to find the solution. One of the solution is x equal to the theta, as usual. Let's see if you get more solutions. You see that is going to be the case. That is going to be the case. So your first solution is going to be in the first quadrant. Okay, this is going to be your data. You get your first solution. But remember the period of a tangent function? The period of a tangent function was pi, not 2 pi. So the first one is going to be pi. The other one is if you add the, okay, if you add the pi to it. Because if you add the pi to it, you are going to be here, you see? You are going to be here, and this is going to be what? This is going to be the pi plus theta. You know that the tangent is positive here, and the tangent is positive in the second quadrant. So you get the first and the second, and you can go on forever. So for this one, it's very easy. X is equal to, you have to have the n pi because the period of a tangent. So it's going to be n pi. Okay, it's not 2n pi. Is going to be, okay, so it's going to be n pi plus theta. Again, when n is equal to the 0, positive, -1, 2, etc. That's a tangent equation. Okay, cotan is the same one. Similarly, if you like, I'm not going to do it, but just write it down. Similarly, if you have a cotan of x is equal to the cotan of theta, then x would be n pi plus theta. Okay, but we usually go with the tangent. So this is going to be the general solution of the tangent equation. Okay, that's going to be the general solutions of the tangent equation, of the tangent equation. Okay, so this is the 3 group of formulas that you have to memorize to get through these functions or these equations. Okay, so we are going to give you examples, some nice examples. We give you all of these would be covered in your next test or next quiz. That first we have the quiz number 3.
Yes.
We're just focusing on these equations only because they are very important. Okay, so let's do it. Let's see what's going to be the, in action. If you want to do it, I just give you the first group that I just, use in calculus. Just see how we're going to do it. There you are. So what we'd like to do is, example. We want to solve each equation. Okay, solve each equation. You start with this one. Very popular. 2, let's say number 1. Number 1, let's say 2 sine x minus 1 equal to 0. Most of the time in calculus, this is all you are going to do for us.
Yeah.
Now, you will see the unknown is sine x. You have to isolate it. You know that add, subtract, like when you solve for x, you are going to solve for what? You are going to solve for the, okay? We are going to solve for the sine x in this equation, okay? So the solution is going to be
2 sine.
carefully, you just, that you isolate the sign. Is the 2 sine x equal to the 1. So the sine x would be equal to 1/2. Okay. Now you go to the table and you find out the sine of angle is going to be 1/2. What is that? So
I6.
it's going to be pi 6. Okay, so the sine x is equal to the sine of pi 6. And you know the general solution for the sine equation. Remember, x is equal to, around the circle, 2n pi plus pi 6, because one of the solution is pi 6, remember, the other one is pi minus pi 6. The other one was x equal to 2n pi plus pi minus pi 6. Okay, plus pi minus pi 6, which is going to be 6. It's going to be what? 5 by 6. It's 150 degrees. So, this is going to be one group of the solution. Okay, you simplify this one, so that give x equal to 2n pi plus 5 by 6. This is going to be the other group of the solution. Okay, but you mentioned that n is equal to the 0, or just say n is an integer. We accept it. So these are going to be general solution of your equation, and with that, nothing else is given to you. I'm going to change it. I'm going to tell you what is going to be those special one. And since no information is given, so we are going to give us the general solution of your equation. Okay, any question? Ready for another one? So let's have another one. Another one is going to be this one. Okay, going with the okay, I'm going to go with the same one, but I change it a little bit. Okay, so how about, let's say, radical 2 sine x, radical 2 sine x plus 1 equal to the 0. Okay, and they may give a condition here. See, they say when x is between 0 and 2 pi. You see, if they write this one, they are interested only in, we say, special equations, the special solution. The solution that's going to be between 0 and 2 pi. This means you are not going to go around the circle. You just find some special one for us. These are going to be much easier to find. And in calculus, most of the time, this is the case. Now, how are you going to do it? You just ignore this one. Just go ahead. And, okay, so solution is going to be
By 4.
we have to isolate it, okay?
Yes.
So it's going to be radical 2 sine x, okay, equal to the -1. Then you find the sine x. Sine x is equal to the -1 over radical 2. Okay, you know that you just multiply by radical 2, the top and the bottom. So it's going to be radical 2 over radical 2.
Minus by 4.
Okay, let's see. So we get the sine x equal to, okay, negative radical 2 over 2 to get these numbers. Now, how are we going to find it? You see, sine x equal to the negative radical 2 over 2. You go to unit circle chart that you have. You see the chart that you have. This is going to be the case on the chart. You see the sign is negative. So when the sign is negative, you are going to be either here or you are going to be here. Okay, if you are going to be here, you can see it on your table, if you like, to get these numbers. So how are you going to get it? So the positive radical 2 over 2 give you pi 4.
4.
But this is going to be what? This is going to be pi 4 plus 180. It's a pi plus, you know, this is going to be pi plus pi 4. Pi plus pi 4 would be 5 by 4. So this would be one of the solution. Okay, so that's 45 degrees, 180, so that give you 225. Now this one over here is, you see, if you go around, it's 360 degrees. Okay, 360 degrees minus pi 4. Okay, which is going to be what? This is going to be 11. Yes, 11 or 9. What's that?
7
Seven,
pi.
7 by, yes. 7 by 4 is going to be 7 by 4. 7 by 4 would be, that give you, yes, that give you 305 if you like, or 45.
315.
315, yes, 315, very good. 315. You see, since they ask you what is the solution between 0 and 2 pi, this is the only solution that you have. You don't have to go to the, you can write the general solution and find it. But this is the way we want you to do it for us. Quickly, just have a look and get the result for this one. You can write the general solution and just then find a specific one, but this is the way we do it, and this is the way you got to use it for for the application in future. So since they ask for the 0 and 2 pi, just 1 around the circle. So this means the solutions are going to be, one of the solution is 5 pi 4, okay, and the other solution is going to be what? Is going to be 7 pi 4 to get these numbers. Okay, so in this format, you just get it quickly to get these numbers done. If you don't want to use this one, it takes times. Okay, I just do it, but I don't want you to repeat it. Any question on this one? So if they ask for the specific solution, just get your unit circle type, circle. Okay, you know that you are going to have two solutions. It's very easy. You have to be in the third quadrant on the fourth one. So from the table, you find out that you get a 5 by 4 and the 7 by 4 to get these numbers. Okay, any question? So let's give you a remark. Suppose you want to make things difficult for yourself. Okay, so this is a method 2. The method 2 is, you may say, oh, I don't like this method. I like to get my general solution. Okay, if they ask for the general solution, you see this is sine x equal to the negative radical 2 over 2. And from the table, you find out that this is sine of 5 by 4. So this is going to be equal to the sine of 5 by 4. Okay, now you write the general solution. What was the general solution? The general solution is x equal to the 2n pi. Remember 2n pi plus theta, which is going to be 2n pi plus 5 pi 4. So this is one group of the solution. The other solution was x equal to 2n pi. 2n pi plus what? 2n pi plus pi minus theta. So it's going to be 2n pi. Okay, 2n pi plus pi minus 5 pi 4. Okay, 5 by 4, and if you simplify it, what is that? That gives you x equal to the 2n pi minus pi 4. You see? So your general solution, you see, these are going to be your general solution of the equation. Okay, any question? So let's see what would happen now. I'm just writing down over here. So you find the general solution in this case. General solutions. So your general solution is going to be two groups. X equal to the 2n pi. Okay, 2n pi plus 5 by 4. Okay, and x equal to 2n pi minus pi 4. Okay, minus pi 4. These are your general solution. Okay, so these are going to be general solution, but you can use n equal to the 0, positive negative 1, positive negative 2, etc. But you are not done. Why? Because they just ask for the solution between 0 and 2 pi. So how are we going to find the solution between 0 and 2 pi? You have to substitute the n to get those numbers. Okay, if you stay with this method, you're not done. You have to put, for example, n equal to the 0. You see, if you put n equal to the 0, from the first group, you get what? N equal to the 0, you get x equal to the 5 pi 4. That is the first one. Okay, from the second one, you get what? You get negative pi 4, which is no good. This is no good. Why? Because they ask for the solution between 0 and 2 pi. So you get one solution here. Okay? Any question? How are we going to get the other solution? You continue. You see this is n equal to 0. You put n equal to 1. If you put n equal to 1 in the first one, that gives you 2 pi plus pi 4, you are over. But if you put n equal to 1 here, that gives you 2 pi minus pi 4, that gives you 7 pi 4. You see? You have to continue to get all those solutions over there, okay? So I just want to have it in this page, so I just continue. So that's why you have to use the first method. So if you put n equal to 1, if you put n equal to 1, n equal to the 1, you go to the first equation. If you go to the first equation, you'll be over. So x would be 2 pi plus pi 4, which is no good, because you want to be between 0 and 2 pi. But if you substitute in the second one, that gives you 2 pi minus pi 4. And that gives you the second solution that you have, 7 pi 4. Okay, so you need to continue the n to get your, to get your proper solutions that you need, because you know that you have to find two solutions. And so these are just to tell you that how these formulas works. But in application, we'd like to get it right away. If they ask for the 0 and 2 pi, don't bother to write the general solution. Okay, just get it. You can get it from your table right away. But if they ask for the general solution, if they don't say anything here, so on the test, that's going to be the case. If we don't say anything here, so this means you just write the general solution for us and you're done. Okay, but if we give you information, stay between 0 and 2 pi. Almost all the problems in calculus would have this one. There are only some in calculus 2 that you need to take care of it. Otherwise, we go with the first method. Any question? So that was with the sine. Let's have something with the cosine to see what's going to be the technical points that you may have to. Okay, to continue. Are you done?
Yes.
Okay, let's see what is going to be something with the cosine. The cosine is easier of the sine. Okay, so check this one. We want to have again. I'll go with this one from calculus. This is going to be 2 cosine x. Okay, plus 1 equal to the 0 cosine equation, and we give you the condition. So you don't have to, you saw that you are not going to make it difficult. You are not going to go with the, okay, general solution. So we have to isolate the cosine first.
Yeah.
So solution, easy to isolate. It's going to be 2 cosine x. Okay, it's going to be 2 cosine x equal to the negative 1. Okay, is equal to the negative 1. And then cosine x is going to be negative 1/2. Again, quickly, you go to the circle and find it. This is a specific solution. So
Pi over 3.
Pi for the negative. You say this is going to be the cosine. You want it to be negative. You know that the cosine is negative where? The cosine is going to be negative here. So one of the solution must be here. Okay, and the other solution is here.
Yes.
Okay, and that's it. Yes, for the positive one, this is the cosine of the 60 degrees. It's a pi third. Okay, so over here is going to be what? Is 180 minus pi third, which is okay.
Pi over 3.
No, 2 pi third, yes? 120.
Mm-hmm.
2 pi third.
And 4 pi over 3.
See, 4 pi third. So it's 120 and 240. Okay, so x is equal to the 2 pi third, 2 pi third, and x is equal to the 4 pi third. And we're done. Okay, so you don't try to write the general solution for this one because you haven't been asked for. Okay, it's just a specific one. So we go over the specific and then we are done. Okay, any question? Now let's change it a little bit to get another one of this format. That's it. Let's go with the one with the tangent. Just make sure we get everything right. Okay, and then we come back again. So for the tangent, let's have something straightforward. It's a tangent of x, okay, minus a radical 3 equal to the 0. No condition is given, so you have to find the general solution. Okay, so the unknown is tangent, so we solve for tangent. So that's going to be the solution. Okay, so this is going to be the tangent of x, which is going to be equal to the radical 3. So you go to your table and you find the tangent. You know, the radical 3 is going to be the tangent of the 60 degrees. Okay, so it's going to be the tangent of, okay, 60 degree, which is going to be pi third. The tangent equation, the period is pi, so it's a straightforward. X is equal to the n pi, okay, n pi plus pi third. N pi plus pi third, and you claim that the n is going to be, can be 0, positive negative 1, positive negative 2, forever, and you're done. Okay, so the tangent is easy equation to find. Okay, so we solve for the tangent of x, and we get the radical 3. Radical 3 is a tangent of 60 degrees, and then you're done. Any question? There is one interesting equation for the tangent. You have to know this one. So let's take care of this one first. Okay, this equation is very popular in various parts. This is it. Suppose you want to solve this equation. This is the tangent square of x, okay, minus 1 equal to the 0. Okay, and they give you the restriction of, would like the x to be between, okay, x to be between, let's say, 0 and pi, or 2 pi. Okay, you see this is tangent squared. You can, you can solve the equation if it's going to be tangent. Any suggestion? What are you going to do to take care of these powers?
Square root or
Kind of square root. What do you mean by square root? Where do you use the square root?
not sure.
Yeah, that's correct, but you have to do something else to take the square root.
Add the one to the other side.
Yeah, that's it. We can add 1 and then take the square root. Or just factor it. Tangent of x minus 1 times tangent of x plus 1. Okay? It's just, it is. I just go with the factory just to remind you that we may have
Yes,
to
yes.
this type of operation. So tangent of x minus 1 times the tangent of x plus 1 is one option. The other option is as, okay, Aaron was talking about, this is the other option. You may go tangent of a square of x equal to the 1, and to take the square root, so the tangent would be positive negative 1. Okay, so we have two options. In this case, we will get it because we get from the first one tangent of x minus 1 equal to the 0. That gives us a tangent of x equal to 1. And from the second one, tangent of x plus 1 equal to the 0. So that gives us a tangent of x equal to the negative 1. So you have two equations to solve, okay? So you take them one by one, and then you take care of it, okay? So we start with this one. So we say, oh, I have a tangent of x equal to 1. Okay, now you check 1 is very popular, is a tangent of 45 degrees. And you have to know this one for the tangent. So that give you pi 4. Okay, for the pi 4, this is going to be the case. You have to write the general solution, then find out how many are going to be between. Okay, and this is between 0 and pi, you get only one solution.
Mm.
Okay, so the solution is going to be, I rewrite it. So it's a tangent of x equal to the tangent of pi 4. Since they just want a specific solution, so we just give them the specific solution, pi 4. Okay, if you write the general solution, it would be n pi plus pi 4, then you have to replace the n by 0 to get it. Okay, so that would be easier. This is one solution, but you're not done. You have to take the other one. So the other one is the tangent of x, which is equal to the -1. You know that the tangent is negative in the second quadrant, and this is going to be the tangent of, okay, 3 by 4, 135 degrees, if you like. Okay, this is going to be 3 by 4, and so it's 135. So we have a tangent of x equal to the tangent of 3 by 4. So that gives you x equal to the 3 by 4, and you're done. Okay, so this is the so-called the tangent equation that we are going to have this one. Okay, any question?
No.
Now, these are some, we call them, specific equations, if you like. So nicely sine, cosine is given to you, then you'll be able to do it right away. Now, most of the time, you'll be all right by knowing this group, and then you'll be done. But in application, there are a group of them, then we call them quadratic type. Okay, so these examples are going to be very important. We give you a couple of them as one question in your next quiz. So we want to, I'm going to write a quadratic type, if you like. Quadratic type equations, if you like. It's going to be happening for the sine and the cosine, very popular. Okay, a very popular case. So what we'd like to do is we'd like you to solve each equation. Solve each equation. There are two possibilities, sometimes three. And it's very, very popular, very popular. Okay, let's try one of them. Okay, it can come with the sine or cosine, and this is it. So the equation is 2 sine square of theta. Okay, 2 sine square of the theta minus 3 sine of theta plus 1 equal to the 0. And the theta is between 0 and 2 pi. We want to solve it. Okay. Now let's see why we call it quadratic. You see, if you take, if you suppose this sine of theta is something, you can call it u if you like. I write it down, but in practice, we do it in the short form, just to remind you that suppose we take it to u to be tu to be sine of theta. Okay, this is going to be sine of the theta. So u squared would be sine square of theta. Okay, so now your equation is going to be what? So your equation is going to be 2 sine squared would be 2u squared. You see, 2u squared minus 3u plus 1 equal to the 0. You see, now this is a quadratic equation. That's why we call them quadratic type. So you go ahead and solve this equation. You can factor it if you like. Okay, if you feel comfortable, you can factor it, or most of the time you can use quadratic formula to get it. Okay, I just use quadratic formula to tell you that it's not the case that always are going to be nice. Okay, but you can factor it if you like. So I just use quadratic formula to solve it. So this is going to be quadratic formula. Remember, negative b plus or minus radical delta, or just b squared minus 4ac divided by 2a. Okay, but again, I tell you that it's factorable, but just in case. So negative b would be negative 3. That's going to be plus or minus. B squared would be negative 3 squared. Okay, minus 4ac, 2 times 1. Okay, divided by the 2a is going to be 2 times 2. Okay, you continue, simplify it. So your u is going to be what? This is going to be a positive 3 plus or minus the square root of, and that gives you 9 minus 8. Nice. And 4. So that gives you 3 plus or minus radical 1 over 4. The radical 1 is 1. So you would be 3 plus or minus 1 divided by 4. Okay, you know that we are going to have two solutions. If you go with the positive 3 plus 1 over 4, that gives you 4 over 4, which is 1. If you go with the negative, it's going to be 3 minus 1 over 4. So that gives you 2, 4, which is a half. So you have two solutions. U equal to 1 and U equal to the 1/2. Any question? But we are not done. What is U? You see, U is sine theta. So you go back and you are going to take care of the sine. Say, okay, U is equal to 1. But what is U? U is sine of theta. Sine of theta equal to 1. So sine of theta equal to the 1, unit circle, you know that this is going to be the sine of 0. Okay, you know, it's a specific one. This is it, the unit circle. You know, we can use the table and find it right away. So this is it. So you have two solutions for the sine. Okay, sine of the theta equal to the 1. You know that one of the solution is going to be pi half. Okay, pi half, and the other one is here, 3 pi half. Okay, oh, I'm sorry. This is going to be only just one solution. 3 pi half would be what? Would be negative 1. So sine of the theta equal to the 1. Between 0 and 2 pi, you have only one solution. Okay, so that gives you theta equal to the pi half. Any question? Okay, and you get only one solution because this is going to be pi half. You want to be between 0 and 2 pi. So the other one is going to be have to go around the circle, but this is a specific solutions. Okay, but we are not done because we have another u. So the other u is u equal to the 1/2. But what is u? U is the sine. So that gives you the sine of theta equal to the 1/2. Again, you want it between 0 and 2 pi. You know that the result is going to be what? If you check it in the first quadrant, this is the sine of the 30 degrees, which is going to be pi 6. And in the second quadrant, you will get it. It's going to be 150 degrees. Okay. So this is going to be theta equal to the pi 6 and the theta equal to the 5 pi 6. So the solutions of your equation. Okay, the solutions are going to be, let's see it, theta equal to pi 6, 30 degrees, pi half, 90 degrees, and 5 pi 6. Okay, so this is very popular case, the case with the quadratic one. Okay, so nicely, if you feel all right, okay, you can you know, just skip the u part and stay with the sine really. And instead of a u, write sine of theta equal to pi. It's not a big deal. Then you are not going to be confused, you know. But if you feel comfortable to be able to just do it right away, we don't mind. you can factor it right away. But the case with the quadratic formula is going to be very popular. So you have to be, okay, you have to be ready for it to get this number. Okay, so that was the case with the sine. You can have a similar case with the cosine. Okay, let's see if we get, just let me just give you that example too, so that you'll be ahead to study these. Okay, any question on this one? So
No,
that's, yes, question? Okay, this is one we call it type 1 of the quadratic. What's going to be type 2? There are only 2 types. What's a type 2? Type 2 is this one, you see. 3 cosine of the theta plus 3 is equal to 2 sine square of the theta. And the theta is going to be between 0 and 2. Let's see what is special about this one. Any suggestion? What's special about this one?
We change sine square.
That's it. You see the
Uh,
yeah, 1
minus
minus
cosine.
that's cosine squared. Yeah. You
Yeah.
see the point about this problem is you have 2 types. You see, you have a cosine and the sine.
Mhm.
You can't do it. You have to have either all cosine or you must
Yeah.
have all sine.
Uh-huh.
So you try to change one of them to the other one.
Yes.
We cannot change the cosine into the sine, but we can change the sine. That's easier. You have a sine square. So they may give you sine square or they may give you cosine squared. Okay, if it's going to be sine squared, it's 1 minus cosine squared.
Mhm.
Or you know that the other one is going to be 1 minus cosine squared. So it depends on the given one. So in this type that we call it type 2, you have to change it first. Okay, if you change it, that give you the other ones. So you just remind you that note that I'm going to change the sine square of theta into what? 1 minus cosine square of theta. Change it carefully. Okay, if you change it carefully, this is it. We have a 3 cosine of theta already plus 3 is equal to the 2 times. You have to use parentheses. It's going to be 1 minus cosine square of theta. Nicely distribute. Do the algebra part carefully. It's a 3 cosine of theta plus 3 equal to, distributed, 2 minus 2 cosine square of the theta. You see now we have cosine, cosine, cosine. Move everything to one side to make it into quadratic equation, okay? You must have 0 on the other side. So I'm going to move this one, add and subtract. So what I do is, this is it. I start with this one. So I bring it here. That give me 2 cosine square of the theta. Then I have a 3 cosine of theta. Okay, I have a 3 here. And I move the 2. So that give me minus 2 equal to 0. Any question? So nicely move everything to one side. Simplify if you can, it's possible. That give you 2 cosine square of theta. Okay, and that's a 3 cosine of theta, but this would be 1 equal to the 0. Okay, so you get a very much similar equation that we did for the other one.
Yeah.
Now it's a quadratic, but it's quadratic in cosine, doesn't matter.
Mhm.
It's going to be in cosine, not a big deal. Okay, so if you don't want to go through that you can directly write the formula. You see, you said u equal to, but you can say cosine of the theta is equal to, just use the quadratic formula.
Mhm.
Okay, that's quick. So it's going to be negative b. Okay, negative b is 3, so it's going to be negative 3 plus or minus b squared is going to be 3 squared minus 4 AC. So that give it 2, 1. Okay, and divided by 2a, 2 times 2. Any question? So, you can change it to U if you like, but this is an option. We did it so that to show you that how we change it, but otherwise, make sure to start with the cosine. You have to simplify this one. So that gives us a -3 plus or minus. Inside is going to be 9 minus 8, the same thing. And this is going to be 4. So that gives you cosine of the data is equal to, that would be -3. This is going to be 1 again, radical 1. Okay, so this is going to be plus or minus 1 divided by 4. Okay, so this is, if you want to, you can continue, is a -3 plus or minus radical 1 over 4. Okay, now two solutions again. If you go with the positive, it's a -3 plus 1 over 4, which is a -2 over 4, which is a -half. And this is a -3 minus 1 over 4, which is going to be -4 over 4, which is a -1. Okay, so you have two solutions. You have to check the cosine of the data equal to the -half, and you have to check the cosine of the data equal to the -1. Any question? Quickly, we can find it from the table. If a cosine of the data is equal to the -half, two solutions. A cosine is negative in the second quadrant and the third one. Okay, so you go to your table and you get it right away. This is cosine.
2 by
So you
by
get one of
there.
them here.
2 by 12.
Here. You know that the positive one is
2 by
60
12.
degrees. Okay, it's going to 2 pi there, 120. And this is going to be what? 4 pi there. Okay, 120 and 240. You have your unit circle. You get it right away. So the data is equal to 2 pi third and the 4 pi third. This is the first set of solutions. Any question? But remember, you have one more. Cosine of the data equal to the -1. And the -1 is the cosine of the pi. Okay, so you get only one solution for this one. So this is just data equal to the pi. So the solutions of the equation, solutions are going to be data equal to, that's it, 2 pi third. Okay, there is no order to write it down, but I write it in order. So it's going to be the pi and the 4 pi third. So you have 3 solutions. You see, that's a quadratic type. These are the most important one. If you know only these examples, you'll be fine. If you want to take calculus 1, okay, not calculus for business, just calculus 1, and you'll be fine for this group of the problems, and you use it in several places. There are a couple of, yes.
Did you use it in other calculuses or just the first one?
It used in the first and the second.
Oh, okay.
First, second, the third, quite a lot.
Okay.
You see, all of them would happen in those courses because there are going to be many application problems if you're just doing related to the physics. Most of the time you will arrive at one of these equations, so you have to solve it. But for calculus 1, that would be the case. You have to solve the equation in several places. But it's going to be more technical in part of the calculus 2, but very much so in the case of calculus 3. So that's going to be, I usually review this one at the beginning of my calculus class, just refresh their memories, just make sure they know it. Because at the university, when we teach, this is a policy over there that if we want in any question, any quiz and the test that we give, we should give one problem related to the trigonometric one. And these are the ones that you need. Okay, otherwise you'll be fine. You don't need anything else really.
Okay.
Okay, so there are a couple of more technical ones. We talk about it and next time, but otherwise we are done. But we give you a review for your next quiz. I posted that one for you. You get all these sort of equations that we need in order to get through it. And that's it. Any question?
Do we have any homework assigned this next week?
For yeah, for your quiz. Yeah, I'll check it and then I
Okay.
send the numbers. Yes, I do that.
Okay.
Okay, that's it. Any question? I try to grade your tests quickly. You will see them probably over the weekend, and then we can talk about it and just keep going. That's it.
Thank you, teacher.
Okay, have a good one and take care.
Thank you, teacher.
I
See you
check.
next week.
Okay, I check to see if there any grade anything was missing. Seems to be everything all right. There were a couple of them. I fix it. If you feel that there is something is missing, just check the grade book and then let me know. Then I can fix that one too. Okay.
Yeah.
So that's gonna be fun. Okay, have a good one. Take care. Bye-bye.
Thank you, teacher.
Thank you.
We appreciate it. Thank you.
Okay, bye-bye. Thank you.
Bye-bye.